All right, so macOS security for MacAdmins. So that's sort of the topic that I'm wanting to talk about today. But before we get into that, a little bit about me. So MacAdmins podcast, hoping a bunch of you can stay. Thank you, Tom. Hoping a bunch of you can stay back later on this afternoon and have a listen to us, and feel free to heckle. It'll be great to get some crowd noise and some participation there. Also help to run Melbourne Apple Admins. We're going to have a meetup on the 19th of April. Come and see any of us from the Melbourne Apple Admins crew, or come and see me if you want to know some more about that. But yes, as Tony said, I'm a senior sales engineer at Jamf here in Australia. But I'm not going to talk about that. I'm going to talk about security on our Macs. But I'm not going to take the usual, this is what you need to do to make your Mac secure path. So there's been other talks at XWorld focused on that. John as well did a great Essential 8 presentation this morning, talking about some of the things you need to consider and the approaches you need to take. And I don't like to be prescriptive as to how people should set up and manage their environments, because as you all know, it really depends on your environment, what your risk appetite is, what your users need to do, and what compliance regulations you have. So what we're going to talk about today is a couple of the underlying frameworks that modern macOS security tools are using, that you can use to protect your users, your company, and your customers. So we all know that Macs don't get viruses right. So we don't need security. This wasn't even really true back in 2006, and it's definitely not true now. So we all know macOS has grown in the enterprise. So how many people here are now working in enterprise, managing Macs in the enterprise? We can see a few hands coming up there. So we've seen Macs go from education and niche areas in the enterprise to now, and being the Mac person, crazy Mac person sitting in a dark room who looks after those funny computers that the marketing team use. We're now at the forefront of employee choice programs, where our devices are the ones that staff demand to be able to do their job. Which means macOS is a target. Unfortunately, Apple didn't sit back and wait for somebody else to do something about that, to provide third-party security frameworks, leave the security up to somebody else. So Apple's taken a really deeply thought-out approach to security and privacy. Controlling the hardware right down to chip design and manufacture with Apple Silicon, through to the various operating systems that run on the Apple Silicon, and then even to the cloud services that we use to link all of these things. So Apple has the ability to ensure that security isn't an afterthought. Now, this document here, who here has read the Apple Platform Security Guide that Tom mentioned before? It's actually an unbelievable read. The lengths that they've gone to ensure that data is protected is phenomenal. Now, the changes that Apple has brought in, which allow them to have this end-to-end security focus, have not been easy for us as Mac admins. So I thought it might be good to show a couple of ways these new approaches are used, and what's happening underneath them, and what we can get out of them. So this is the outdated approach to security. Lock everything down, epoxying USB ports, which is kind of a bit pointless when that's how you power your machines now. It's just as good they've got great battery life. Restricting every single setting. So that's sort of completely at odds with what our users and our employers expect. Not to mention that that's actually not really protecting us from the modern threats of today and tomorrow. So even when it comes down to locking down your machines and applying the security configuration, we've got much more elegant ways of doing this. So we can use configuration profiles, and we can use scripts. We want to come up with a security baseline for our environment that allows people to do our job. So there's a lot of benchmarks we can use, CIS benchmarks, NIST, and they're updated regularly to keep up with the annual macOS release cycle. So it used to be that these benchmarks were sometimes at least a year out of date, and they weren't relevant to what we were needing to do. But we're now seeing those come out almost as soon as the operating systems are released, and certainly in draft beforehand, so we can test that. And the macOS Security Compliance Project has done a great job of ensuring that we have a consistent programmatic approach to selecting and then applying these compliance standards. So most importantly, it's about identifying which particular items from these security benchmarks are appropriate for us, and even at a more granular level. Will a data entry user in finance with sensitive user data need the same configurations as a developer working on building the modern apps that power your organization? So we really need to design what our security looks like. So, we take these steps. We design what it looks like, and then we align or we configure our devices accordingly to what that design is. But then we need to detect. So are the machines still configured the way we need them to be? And is there anything happening on those devices that concern us? And then we need to respond. We take action if something happens, or if we need to modify the configuration, deal with new operating systems. So it's a cyclical approach to security. It's not just the get the arrow dart out, lock the machine down, send it out, and think that we're safe. So as Tom told us yesterday in the opening keynote, this process is ongoing and never stops. So we're going to have a look at this detect approach today and have a look at some of the ways we can find out what's going on our machines that can inform us as to how to then respond, and that can filter back into design and align. So before we get into it, a disclaimer. I am not a security engineer or a developer. I come from a MacAdmin background, and I'm fascinated by the tools that security and Apple have built. So I'm going to try and provide a broad overview of some of the frameworks. I'm going to try and simplify a very complex topic. And so this is undoubtedly going to lose some of the nuances in it, but hopefully it's enough. What I'm trying to do here is pique your interest so you can go and explore some of these frameworks yourself and understand why we've gone through the changes we have and what opportunities we have. So instead of looking at how these tools can be used for preventing malware, I'm going to take the approach of what could these tools be used for that might help a MacAdmin, so we can better frame how they work and the sort of things that happen. So let's go back to the before time. So security tools would capture intelligence around what was happening on a device using a couple of methods. So Apple implemented OpenBSD, an open source implementation of Sun's basic security module, security audit API, and file format. So this provided developers with a stream of data that could be used to identify events taking place on the device. The only problem with OpenBSD was it would report back the queries after they've happened. So it's a more reactive approach to security, seeing what has taken place on your device. It's still in macOS, and it's a really useful source of telemetry. But due to the reactive approach, many endpoint security tools instead opted to use kernel extensions using the KEXTS API. This gave that real-time telemetry and control, but it was an undocumented MAC framework. And so the problem with KEXTS is that they reside in the kernel. They had access to all the things. And they relied on undocumented frameworks, which meant that Apple didn't have to say when something changed. So security tools would sometimes need significant rewrites with a new version of the operating system, or even due to a point or a supplemental release or a security update when we used to have those things. And when it went bad, it went really bad. So Apple went about removing third-party access to the kernel. It wasn't quick, and it also wasn't easy. So who can remember the KEXTS apocalypse as these changes came in? So 10.13, when we all of a sudden had to use MDM to allow kernel extensions, and there was still is a Google spreadsheet with all of the team identifiers of kernel extensions, trying to work out which ones you needed to apply, make sure that the developers kept using the same team ID to sign them. And then we saw things progress, became even more frustrating. Many of the developers using KEXTS got with the program, but a bunch of them didn't. And there are still one or two that are still using KEXTS. So is anybody out there still deploying KEXTS in their environment? Yeah, one hand, two hands. And I can see there are still a couple of things that kernel extensions haven't been able to replicate or provide, that Apple hasn't been able to solve with system extensions. Some large format storage, those sorts of things. It's becoming harder and harder to use kernel extensions, and especially in Apple Silicon, where Rosetta 2 is not able to emulate Intel code. So to replace kernel extensions, Apple introduced system extensions. So these do not reside in the kernel, but instead they get access to Apple-provided frameworks, documented frameworks to perform tasks previously fulfilled by KEXTS. And there's a lot of security around them. So they have to be signed by Apple. And then they require entitlement in the code. So they need to declare which particular frameworks they're using, and they're only allowed to use those frameworks. Now, they need to have user consent unless you're on a supervised MDM. The benefit of this is there's less third-party code in the kernel, so it's a reduced attack surface. You don't have somebody else's code running unfettered in the kernel, able to do and see whatever it wants. But there's also better system stability because you don't have that code in the kernel doing whatever it wants. So one of the frameworks designed to be used with system extensions is Apple's Endpoint security framework. So this is intended to replace the functionality of kernel extensions managing security and eventually OpenBSD. So Apple provided extensive documentation for developers when they were released at WWDC in 2019, and subsequent improvements to the framework have been documented since then. So what does it do? It detects events as they are happening, provides rich metadata about the event. So you get the information about the event that is taking place, but also a whole bunch of other things that you can use to make decisions about the context of that event, who's performing the event, what the impact of that is. It's primarily designed for endpoint security tools, but it can have uses beyond this. So it runs on events that your system extension subscribes to. As they're happening, you can use two different kinds of events. So notification events are what they say. It will tell your system extension about things that are happening. It's informational, but you get that information very quickly. The second set of events are authorization events, where the system extension needs to respond to the endpoint security framework when it's been provided an authorization event to say whether that event should happen or not. So the system extension can actually prevent certain events from actually being able to take place on your machine rather than needing to go in and mop up later. So your system extension subscribes to certain events. So we can see here all of the various types of events and how many of them there are. So there are a lot of them. Just looking at the 15 events alone in file systems, we can see there is a lot going on. So there is an art to building a security tool that uses these events. Capturing that data is the easy bit, but you can see with the volume of data, deciding what data is important and what to do with it is the really challenging bit. So given that it requires a system extension to use the endpoint security framework, how do we give it a kick in the tires? We could write our own system extension. That could be interesting, or we could use some of the tools that the macOS security community has already created. So Jaron Bradley from the Mitten Mac and from Jamf Threat Labs has built ESF Playground. For everyone, there'll be a QR code at the end with links to all of these resources as well. So this allows you to toggle notification events off and on and see the traffic associated with them and work out what sort of results you get back. And then Patrick Wardle from Objective-C has built 3 separate tools for monitoring processes, files, and DNS events. So these are some of the results I got when playing around with things that aren't necessarily security events, but this is how I sort of wrap my head around how this endpoint security framework works. And it was sort of interesting to see, ask MacAdmins what we could detect and how we might be able to use this. So we've heard a few people talking about Nudge today, using this to encourage our users to keep their software up to date. So that's great. We want our users to keep their software up to date. But what if they don't want to keep their software up to date? Users are actually able to unload the launch agent that's running Nudge. It's reasonably easy for users that know what they're doing to get around seeing these prompts. So maybe we can see what the endpoint security framework is doing. So the great thing here is there's an execution event that comes up when this command was run. And there's some interesting things we can see here. So we can see, this is not working so well. We can see here the unloading of that launch agent here. And we can see the user who is doing it. We can see that they did it from the terminal. And we can see a timestamp of when that happens. So all of a sudden, we've got this ability to prevent a user from doing that, or to report back that a user is doing something they shouldn't be doing, and then decide how we want to remediate or respond to that process. Printing was another one that I found really fascinating. So one of my illustrious colleagues at Jamf, Alan Golbig, was looking at a way of detecting AirPrint. This is something that's not able to be blocked natively in macOS. So looking at how we can report on usage. So I've got a link here to a blog with all the details. That'll also be in the QR code at the end, but a fascinating insight to how you can use this metadata to narrow down who, what, why, and where. So we can see here in this execution notification from the printing system, we can see the name of the user that printed, and also the document that was printed. So all of a sudden, this framework is able to give us information back, very specific information about what's happening on these machines that may be either getting around some of our security controls, or things that we don't want to control because we want people to be able to do certain things for their job. Another example I looked at was about application control. So there's a lot of ways to detect applications being installed on machines. Inventory through our MDM. You can use the Endpoint Security Framework to detect directories being written with a trailing .app at the end of the name. But let's say, for example, we have developers wanting to install software while they're elevated as an admin, and we want an audit trail of what they're doing. Now, not every developer is going to be installing applications that are an app bundle. Some of them are going to be installing executables, for example, that are in user local bin. So how do we work out what they're installing in there without writing complex scripts or extension attributes? I know I've done that before. I'm sure many of you have as well. And you end up with a really complex workflow that needs constant looking after to keep those sorts of things going. So I'm going to use an example here of an executable. So there's a tool called Mist. Is anybody here using Mist for downloading operating system updates? Mindy Gill over there is using it for from Dropbox. Fantastic tool. Maybe not the sort of thing you want to stop people from installing on their machines, because it's actually really useful. But you know, Nindy's done a great job, so I thought I might, you know, pretend it's malware for a little bit. So we can see in the Endpoint Security Framework the sort of information we get. So we can see here the user's downloaded the package. It's on their desktop and they've opened that file. We can also see, as part of the installer sandboxes getting opened up in library, the bill of materials getting created. We can actually start to see that binary getting laid down in that install sandbox. And then the last thing we can see is that actually being moved across into user local bin Mist for the CLI framework. So you can see there we've actually got a lot of information we can detect about what's happening on these devices that fall outside of the standard scope of looking for app bundles in /applications, and being able to allow users to do certain things, but being able to really focus down using the Endpoint Security Framework on certain things that we don't want them to be able to do and certain things that they are able to do. So I'd really encourage you to have a play around and see what the Endpoint Security Framework can do. It can also give you a really good insight into what your security tools are doing for detecting malware and pattern behavior, and how this is working, and where there may be challenges with resources on your machines, but also why there are probably fewer challenges with resources in your machines due to this being a system extension, the Endpoint Security Framework, rather than a kernel extension that's just controlling everything and making its own choices about what's happening. So another thing I had to play around with was unified logs. Now, unified logs are most definitely not a security tool. So why are we discussing them here? They're used for troubleshooting issues, but they're also a valuable source of context that can be really powerful as part of your security and response tool set. So a quick step back in history. What are unified logs? So Apple introduced them in macOS 10.12 Sierra in 2016. So prior to this, we had common Unix logs, the Apple system logs, that were plain text log files residing on device. So Apple wanted a single efficient system of logging that maximized the information collected. Much like we see an endpoint security framework, we want lots of information, but they want to ensure that there's user privacy. So the logs are ephemeral. They only exist on the device for a short amount of time. Quite a lot of them actually only exist in memory for a short amount of time, and they're very verbose. But that means we can target them for what we're looking at. So unlike the previous Unix logs, unified logs don't reside in flat text files that you can read in a text editor or copy across somewhere else. They're stored in compressed trace v3 files in directories in VarDB diagnostics. Apple does not provide access to the contents of these files. You're expected to query them via the terminal or the console app or via the command line. So only some of the logs are stored in these files. Many are kept in memory and never really appear on disk. The full stream of logs are so verbose that if macOS kept all of the log files, that would equate to around 50 gigabytes of data a day. So let's look at what that's going to cost to keep all of those logs. So let's say, for example, we want to ship all of those to Splunk. So 50 gig a day, let's say we've got a fleet of 2,000 Macs, that's 100 terabytes a day. Now, Tom has showed us what the MacAdmins Foundation unit of fiscal measurement is. So this is 4 Ferraris worth to keep all of the logs of your machines. Probably not something your organization is going to budget on. So we need to query these logs and find the information that's important to us. So we can see the unified logs have a standard format. We've got information about time, processes, activities. Then we get the actual process, and then we can narrow down via subsystem and category and then get to the actual event message. By default, Apple, who we know are concerned about privacy, masks information that might identify a user or other information that could be private. But we can disable private data with a configuration profile. But be careful about that. Where are you storing these logs? What information is in those logs? You can enable those configuration profiles narrowed down by subsystem and category. So it's really important, if you are doing that, to be intentional and considerate about what you're doing and be granular. Enable private data where you need to and ensure that those logs are being kept somewhere safe, somewhere secure, somewhere controlled. So let's have a look at what we can do with this. So privileges, we've had a few people talking about SAP privileges at the moment. So as was mentioned, it's got a really useful unified logging system here. So we can actually leverage that here. So you can use the NS predicate language with the log command to narrow down what you want to know. So we can see here on a demo user I set up, we get this information here. So we get timestamps of when the user gets admin rights and when the user is demoted back to having standard admin rights. And then we can ship that information. So Martin showed us some great things yesterday about using Splunk. Stu had some other ways about leveraging data. Here's some data here that we can use to know when a user is an administrator and when they're not an administrator. So we can then compare that with other information about what's being installed on their device. Another one here is complete brain freeze, AirDrop, there we go. Sorry, AirDrop, thank you. That was a test, audience participation. Let's just say, and it's written here right in front of me, let's just say we restrict AirDrop in our organization. We've applied the configuration profile, we've scoped that accordingly. So we think that we have AirDrop secured. Maybe something's changed. Maybe we're having a bad day when we did the scoping on that. Maybe somebody else has made a change that impacted something else in our organization. So we can actually detect AirDrop traffic going on in our device. And we can actually even see the documents that are being shared. So in your organization, that may be appropriate. You may have people who require AirDrop access for certain things, but you want to restrict certain areas of their machine where AirDrop is not approved, AirDrop is not recommended, AirDrop is not allowed, and so we can do that via detection to see if people are breaking those rules. So we've got all of this data. We can see that there's a huge amount of events that we've detected. So we can see threat hunters will use these tools to detect patterns of behavior by malware, known malware, unknown behavior. But we can also use this to detect patterns of behavior that aren't malware, but maybe an indication that our desired configuration hasn't been achieved. Incoming SSH attempts shouldn't be possible, yet we're seeing events to indicate that this is actually happening on our devices. Is it malware that's reconfigured our machine, or is it a misconfiguration of our own that's exposed the device to opportunistic attacks or a curious user? So here's a simple example of a Splunk dashboard. So in this case, I used Jamf Protect to ship the endpoint security framework data as well as the unified log events to Splunk. And so we can use these different sets of data to create a dashboard item. So we can see at the top there, I've got timestamps from the unified logs of when users were getting elevated to admin rights, using the difference in the timestamp of when they went to admin and when they went back to standard user to show a duration. And then, we can also get somebody to create a really amazing Splunk query to correlate those times when someone was an administrator with applications that were installed on their machine. So we can maybe feel more comfortable about letting someone be an administrator because we know we can have an audit of what's happened on their device. Now, interesting there, the top application that I've got here, that's actually not in the applications folder. It's not in user local bin. Someone's actually just running VLC from their desktop. So you can see here, we can actually use these tools that we've got to find out things that we're not able to restrict by someone being a standard user. They may have found the edge cases of getting around some of our tools like Santa that's been mentioned a few times. Santa may stop the application from running, but we can audit that it's actually ended up on their device, and you can have a discussion with them about, hey, why was that happening? So we can use, if we look back at this slide, this is where we can use this data to detect and respond to not just attacks or malware, but user behavior or configuration skew. So that's sort of where I approach this from, finding out about what opportunities these new tools have, but also to put me in a situation where, rather than being frustrated at the effort we had to go through to get rid of kernel extensions and move towards system extensions, to actually reframe my expectations and understand why Apple has done this, but also to be able to look forward to the opportunities that different vendors are giving us. A quick warning as well, depending on what network you're on, the blog that I've got this on, choosing ransomware, the name of my blog. I know there's a certain bank that had to ask to get that opened up on their firewall. That was an interesting discussion with their security teams. But yeah, I hope this has been interesting for you. I'd really recommend going out there and having a play around with some of these tools and understanding the power that you can get out of things like the endpoint security framework and unified logs. So any questions at all? James? Yep. I'll repeat it for the recording anyway. Yeah.
Well, you don't have to.
Yep.
With your detection around AirPrint and the name of the document that's getting printed, can you also apply that to just regular printing? So allow users to print, but still monitor the documents to flag that.
So for the recording, the question was, can you apply that to different kind of print jobs? I think so. It may be a slightly different technique, but I'm getting a thumbs up from the back. Yeah, so the beauty of the endpoint security framework is, as we saw with the dog with the tennis balls, there is a lot of data there. The trick is finding the data that you're looking for. And so I'd recommend having a look at that blog post of Alan Goldwig's, the process that he went through, showing how he went backwards and forwards and moving around using different techniques to actually find the process that he was looking for. And what was causing this was, it was a real benefit for me in understanding that.
Can you recommend any great products that might make use of unified logging?
I mentioned a few products before in there. Look, there are lots of ways of accessing the unified logs. What sort of different products are people using? I know some people have built their own tools to capture unified logs and then ship them to self-hosted solutions. I'm from Jamf. Jamf Protect is a great tool for doing that. But there are lots of tools out there. Find a tool that works for you. you.